Hello, my name's Thanom and I'm from UNSW. Today I'm working through some of the problems from Math 1011 Calculus in the section on limits. So we've got some trigonometric limits here. One of the key ideas that's written in a box above this problem set is that the limit as x tends to 0 of sine x on x is 1. That's a very useful fact to remember. But 7a here isn't the limit as x tends to 0, it's the limit as x tends to pi on 2. Sine x over x, that's a continuous function everywhere except x is 0. So that means it's continuous at pi on 2 in particular. So if it's continuous at pi on 2, then to evaluate this limit, I just need to evaluate the function at pi on 2. So this limit is sine of pi on 2 on pi on 2. That's 1 divided by pi on 2. That's the same as 2 divided by pi there. For part F here, our main idea is that the limit as x tends to 0 of tan x on x is equal to 1. Here we don't have tan x on x, we have a tan 5x. So we really need a tan of 5x over 5x to use this fact about limits of tan. So let's get a tan of 5x on 5x. Let's simplify this expression here. I'm going to take this half out, write it as a half times tan of 5x over x. So I haven't changed the question in any way, I've just written it as a half times this instead. Now I'd really like tan of 5x over 5x here. So I'm just going to multiply top and bottom by 5. So I haven't changed the question at all. So now this is the 5 on 2 times the limit as x tends to 0 of tan of 5x over 5x. The idea is if I had the limit as 5x tends to 0 of tan of 5x over 5x, then that would just be 1, right? This is still 1 because if x tends to 0, then 5x is certainly tending to 0 here. So we can make a formal substitution, but the idea is that this limit here is still going to be 1 because 5x is going to tend to 0 as x tends to 0. So overall, this limit is going to end up as 5 on 2. This last part, h, limit as x tends to 0 of cosec x, I'm going to just quickly go over the graph of cosec x so we can see what's going on here. So remember cosec is 1 over sine. So if I'm going to draw a graph, so let's remember cosec x is the same as 1 over sine of x. So my sine graph starts at 0 and goes up to 1 and down to minus 1, and it also goes down to minus 1 up to 1. That's 2 pi, and this is 2 pi. So this is my sine graph here, and I need 1 divided by this graph. So what happens when I want to sketch y equals cosec is 1 divided by 0 is where my asymptotes are going to occur. So there's going to be an asymptote. We'll have an asymptote right on the axis here because we can't do 1 divided by 0 there. We'll also have an asymptote here. We'll also have an asymptote here, an asymptote here, an asymptote here. Okay, 1 divided by 1 is 1. So my graph definitely goes through 1 here. 1 divided by a half is 2, for example. 1 divided by a half is 2. 1 divided by small positive numbers are large. So this graph tends towards infinity here as x approaches 0 there on the right. Here these are negative values, so x is going to tend towards negative infinity. Right? When this value approaches negative, a small negative number approaches 0 from underneath, 1 divided by a small negative number is huge. So your cosec graph looks like this. This tends towards negative infinity here. This tends towards positive infinity here. So what happens is if we want the limit as x approaches 0 of cosec, right, if we just looked at this section, we might think that that just tends towards infinity because as x comes to 0, it tends towards infinity. But that's only tending to 0 from the right. If we came to 0 from the left, it would actually tend towards negative infinity, right? So on one side it's huge and positive, on the other side it's huge and negative. So this limit actually does not exist. Okay, so we can't even say it tends to plus or minus infinity. It does not exist at all because on one side it's heading towards positive infinity and on the other side it's tending towards minus infinity. Okay, so we can't say anything about that. Oh, actually, we could say something. We could say as x tends to 0 plus cosec x is going to tend to infinity. We could say as x tends to 0 on the left side, cosec x is going to tend to minus infinity. But overall, this limit is not going to exist here.